You might already know how to deal with sequences, so I'm actually going to say hit pause and try these before I go through them, okay? Basically, as stated previously, a sequence is a pattern, a list of numbers that's put together according to some rule. So the question is going to be, for each of these four, can you spot the pattern? And if so, can you also continue the sequence, write the next three terms? All right, so I'm going to say hit pause, take some time on them, see what you can do with them, then unpause. All right, let's look at this guy. The first thing that you're going to want to try to check for in a sequence is, am I just counting by the same amount each time? Because if I am, then it's a real easy sequence to figure out, right? I'm just counting by 12s. Okay, if I want to continue the pattern, I'll continue counting by 12s. All right, so the next two terms would be 53 plus 12, 65, 65 plus 12, 77, and so on. Okay, so my recursive rule is plus 12. Recursive rule plus 12. Okay. If your recursive rule is add the same amount each time or subtract the same amount each time, then we call the sequence arithmetic. Arithmetic sequence. Looks like arithmetic. Arithmetic, changing the pronunciation changes it to an adjective. Okay, it's an arithmetic sequence if you're adding or subtracting by the same amount each time. All right. Second thing you're going to want to check for, if that doesn't work out, okay, if I try subtracting, this is 1944 minus 648 would give me 296. No way. 1296. Let's see. All right, 1296. So that's minus 1296, and from here to here, we got 648 minus 216, and that's 432 minus 432. Okay, so I am not subtracting by the same amount each time. This is not an arithmetic sequence. The second thing you're going to want to check for is whether it is a geometric sequence. Geometric sequences, the recursive rule is multiply or divide by the same amount each time. Okay? So I could check this. I'm going to work with the small numbers. To get from 72 to 24, we divide by 3. To get from 216 to 72, we divide by 3. And I hope that the pattern continues all the way down the line, because if it doesn't, then I made an error somewhere. All right, so we're dividing by 3 each time. And you don't have to have built the problem or be able to do those numbers in your head. You can just use a calculator from term to term and say, for example, 1944 divided by 3, enter, or not that, that's not how you would do it. You would be 1944 divided by 648 and find out that, okay, the factor that I need to divide by to get from here to here is 3. And if I do 648 divided by 216, I also get 3. And if I do 216 divided by 72, I also get 3. All right, that lets me know I'm dealing with a geometric sequence. So if I wanted to continue the sequence, divide by 3 again, we get 8. Divide by 3 again, and we get 2.6 repeating. All right, and you could continue it and get further and further into tough to calculate decimal calculations. But again, calculator, you just got 2 2/3, so 8/3, and then that divided by 3, and you're looking at, that's your next term. Okay, anyway, all right, arithmetic sequences, geometric sequences. If neither of those things work, then you could be looking at a parabolic sequence. I maybe just made up that word, I'm not sure. If I didn't make it up, it's probably spelled wrong. Also could be called a quadratic sequence. Also could be called a, this is the most useful term, second difference sequence. Okay? Second difference sequence. All of these words mean the same thing. Second differences will make the most sense with what I'm about to do. All right? Now, when I'm testing for whether or not this is arithmetic, 9 plus 7 is 16. 16 plus 10 is 26. Okay, it's not arithmetic because I'm not adding by the same amount each time. But if I continue this, 26 plus 13 is 39. 39 plus 16 is 54, or 55. 55 plus 19 is 74. Again, you could be using a calculator, and the way that you would find that red number would be to subtract, right? 74 minus 55 is 19. Okay, so that's what I'm adding here. Now, all right, maybe you can see a pattern, maybe not. There is a arithmetic sequence in the red numbers. To get from 7 to 10, we add 3. To get from 10 to 13, we add 3. To get from 13 to 16, we add 3. To get from 16 to 19, we add 3. So, the differences of the differences are constant. Okay, that's why it's called a second difference pattern. Now, these are tough to recognize, and they're tough to get my next terms because I need to do this, right? I need to figure out what do I need to add by next time, which will be 22. So 74 plus 22 is 96. And then I don't add a 22 again. Now I'm going to need to add a 25. So the next one will be 96 plus 25, which is going to be 121. And then I would have to add 28. And then I would have to add 31. So they're kind of tough to build. But you should be able to recognize them when you see them. All right, let's see. If it's not any of those types, again, when I'm testing for my arithmetic sequence, 2, 11, 13, 61 minus 37 is 24. 98 minus 61 is 37. Okay, you might start to see something like this. 11, 13, 24, 37. 11, 13, 24, 37. If I took second differences for this, we're going to get 9, 2, 11, 13, 2, 11, 13, 2, 11, 13. Okay, this, if I take third differences, 9, 2, 9, 2, 9, 2. All right, so when this happens and you start seeing the differences are repeating themselves, I call this a snowball pattern. All right. I believe the correct term might be Fibonacci. Not sure if I spelled it right. There's probably only one B. Fibonacci sequence. Anyway, here's what's happening. All right, if you see that happening, this is how it's being built. All right, 11 plus 13 is 24. 13 plus 24 is 37. 24 plus 37, 61. All right, so basically the way to get a new term is add the two terms that come before it. So 98 plus 61 would be 159. And then 159 plus 98 would be 257. And then 257 plus 159 would be 416, and so on. All right, so that's how that's built. Okay, those are the four main types of number sequences that you'll see in Algebra 1. You can also get sequences that aren't built from numbers. So draw some lines on here, because I don't know if they show up. 1 cube, and then, or one square, and then we have squares being added to the edges of it. The next term in that sequence would be 3 squares coming off of each edge. Okay. And then 4, and then 5. Right? You could also have letters thrown into your sequence, and I mean, we have the same symbol showing up over and over again, and what is it doing? It's spinning around 90 degrees each time. So the next one would look like this, and then after that we'd be back to our start. Okay. So there are weird sequences that you also might have to deal with. This is where sequences sometimes gets tough for students, because if I put some gaps in here, it gets a little harder to figure out what type of sequence it is. You're always still going to start out and ask the question, is it arithmetic? Because that would make it easiest. So the distance from here to here is 4. The distance from here to here is 4. So I can be pretty confident. Distance from there to there is 4. Very confident. I'm dealing with an arithmetic sequence. So this one is not too tough. 19 then plus 4 would be 23. Double check. Plus 4 is 27. Cool. 31 plus 4, 35. Plus 4, 39. All right, we're good, right? So if it's an arithmetic sequence, filling in the blanks won't be too tough. All right, this guy here, I'm adding 40. All right, so then That's the only piece of information that I have with two guys next to each other. So let's see what would happen if I added 40 here. My next answer would be 120. And if I added another 40, I would have 160, not 320. So what have I learned? I learned this is not arithmetic. All right, I'm going to test for geometric next. How do I get from 40 to 80? I could do times 2. All right, times 2. Let's see if it will work. If I do 5 times 2, that'll be 10. And if I do 10 times 2, that'll be 20. If I do 20 times 2, I get 40. Cool. 80 times 2, 160. 160 times 2, 320. All right, all good. So it's a geometric sequence, and I filled in the gaps. All right, so you kind of just have to test the types of sequences and see if you can find one that works. All right, we got here plus 8, here plus 2. It's not arithmetic. Here times 2.142 and some more decimals. Here times 1.08. Okay, so it's not geometric, so it's got to be one of the other ones. And this will be tough. All right. I know that when I jump over a gap of 2 things, I'm adding 10. When I jump over this gap of 2 things, I'm subtracting 2. And the question is, can I make a pattern in my green numbers right here that results in adding 2 numbers to make 10? All right, so 5 and 5, but 8, 5, 5, 2 doesn't really make sense. 6 and 4, 8, 6, 4, 2 looks promising. All right, 8, 6, 4, 2. What would I add next? I would add 0 next, and after 0, look, I'm going down by 2's. Minus 2, minus 2, minus 2, minus 2, 0, minus 2. All right, now let's see if that will work out. 15 plus 6 is 21. 21 plus 4 is 25. Good. 27 plus 0 is 27. 27 minus 2 is 25. Cool. This is a second difference sequence. All right, because we got our minus 2, minus 2, minus 2, minus 2, minus 2 as our second differences. All right, and we filled in the gaps. Okay. Everything from this point forward is optional. I've shown you what I needed to show you. Basically, what I'm going to do from this point forward is give you a sequence, tell you to hit pause, try it, and then you can watch and see if you got the answer correct. Okay? So each time, pause, try it yourself, and then check against what I do. Question is, what type of sequence is it? What's the recursive rule? And what are the next 2 terms? Recursive rule times -3. Type of sequence, geometric. What are the next 2 terms? Need a calculator. 324 times -3. Negative. Ooh, my fault. -324 times -3 is positive 972. And then times another -3 is that number. All right, but I reversed my negative, my signs, because I put 324 as a positive. So, right. Next one. hit pause, try this. Recursive rule, +5, type, arithmetic. +5, +5, +5, +5, next term 6, next term 11. Alright, hit pause, try it. Alright, this is an arithmetic sequence. +1 is the recursive rule. Alright, ready? Uno, dos, tres, cuatro, cinco, seis, siete, ocho, nueve, diez. Just counting by ones in Spanish, first letter of each number. All right, so this is a weird one, type of sequence where you would just have to see, can I figure it out, can I not figure it out? Maybe you wouldn't figure it out. All I would really want to see in that case is, what are your ideas, right? A lot of times if the numbers get small very quickly, you know that you're dealing with or get large very quickly, you know you're dealing with a geometric sequence. That's divided by 5, that's divided by 5. That's going to be my recursive rule. Geometric sequence. Right. This is a Fibonacci sequence. Or snowball. Three plus 3 is 6. 3 plus 6 is 9. 6 plus 9 is 15. 9 plus 15 is 24. 24 plus 15 is 39. And so on. This is just straight arithmetic. -3 every time. That's the recursive rule. 51, 42, 39. Alright, notice I figured out it was arithmetic because a gap of 2 was -6, which is 3 times 2. A gap of 1 was -3. A gap of 3 was -9, which is 3 times. Negative 3 times 3. Alright. So, 2 patterns going on here. For the number of sides on the shape, it's pretty simple. 4 sides, 6 sides, 7 sides, 10 sides. That means we're just counting by 1 on our sides. So this would be a 5-sided shape, an 8-sided shape, 9-sided shape. Okay. Inside, we got A, G, J, S. All right, G, H, I, J, K, L, M, N, O, P, Q, R, S, B, C, D, E, F. All right, so I think we got 3s and 2s. I think if I take this D, M, P, and just be counting up by threes. B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So it's kind of actually two arithmetic sequences.